So, class, welcome to the lecture number 25th of the course, Power System Operation and Control. So, in the previous three classes, so it was about this unit number fourth. Okay, so due to some reasons, now I am skipping half of the unit number fourth. I am starting unit number fifth directly, and because this unit number fifth, it is a theoretical unit with only, and it will take only 2 lectures to complete this unit. Okay, so after completing this unit fifth, that is after completing the 2 lectures, I will again go back and I will start. I will try to finish the remaining part of the unit number fourth. Okay, because it will take at least three more lectures to finish this unit number fourth. So let's start with unit number fifth today. So the first important topic of unit number fifth is energy management system. Energy management system, in short, it is written as EMS. E for energy, M for management, and F for system. So what is energy management system? If you will see what are you finally consuming? Are you consuming power, or are you consuming energy at your homes? If you will see a consumer, it consumes energy. That's why we are paying for energy. Just look at your electricity bills. It is the unit that has consumes, they are kilowatt hour. Okay, kilowatt hour is nothing but kilowatt multiplied by time. In hours, it is kilowatt hour. So basically, we are paying for the energy we consume, because energy is nothing but power multiplied by time. The unit of power is kilowatt and that of time is hour, so it is kilowatt hour. Okay, so this topic is called energy management system. So energy management system means how will you manage the energy that is generated at the power in the power houses. Obviously that energy will be electrical energy. Okay, and that energy is transmitted over transmission lines, and finally that energy reaches to the consumer via some distribution system. Okay, so in this whole process, okay, that is from generation to consumption, so this energy management system comes into picture. Means you have to manage the energy, and in such a way that your power system, it remains secure, it remains reliable. Okay, and it also means this system, energy management system, it also ensures that your system is operated in a most economical and efficient manner. Means first is safety, that is security and reliability. The second is economy and efficiency. Okay, so let us start this energy management system first. So I am saying this energy management system, basically it refers to a computer system designed specifically for automated control and monitoring of electrical power system. Okay, so anything you want to control, okay, first you should be able to monitor. Okay, that is why it is said that's automated control and monitoring. First we will monitor, and after monitoring, this energy management system, it implements the automated control with the help of the computers. Okay, and the scope of this energy management system, it may span from load dispatch center to a group of power networks. What is load dispatch center? I am saying this energy management system, basically I will tell you about the evolution of the energy management system. First, energy management, it was not named like energy management system, it was named like load dispatch center. Okay, so load dispatch center, you can see, like if you will see in our state, we have two state load dispatch centers. Okay, one is in Srinagar and another is in Jammu, Gladney. Okay, so this is at the state level. Okay, and these two load centers, the load dispatch center, that is state load dispatch center, that one is in Jammu and one in Srinagar, they will monitor the load and generation and distribution of the this generated power among the loads. Okay, of Kashmir province and Jammu province. Okay, so moving to higher hierarchy, then we have northern load dispatch center. So in northern load dispatch center, we have 8 states. What are the states? Jammu Kashmir, Punjab, Haryana, Rajasthan, Uttarakhand, Delhi, and 2 more states are there. I don't know. I don't remember the name of these 2 states. So exactly there are 8 states. Okay. So if you will move up the hierarchy, we have then National Load Dispatch Center. National Load Dispatch Center is located in Delhi. Okay. So if you will see, If you will see, first we have national load dispatch center, means which is at some national level, okay, means at some country level, okay. Then we have, if I will talk about India, then we have 5 regional load dispatch centers. So what are the 5 regional load dispatch center? One is Northern Load Dispatch Center. The second is Southern Load Dispatch Center. Third is Eastern Load Dispatch Center. Fourth, Western Load Dispatch Center. And fifth is Northeastern Load Dispatch Center, which includes the 7 sister states of the Northeast. Okay. So at national level, we have one load dispatch center which is called as National Load Dispatch Center, and then we have 5 regional: Northern, Southern, Eastern, Western, and Northeastern load dispatch centers. Okay. So out of these 5, this Southern load dispatch center, it operates at different frequency. Okay, whereas these remaining 4, Northern, Eastern, Western, and Northeastern, they operate at the same frequency. However, this Southern load dispatch center, it operates slightly at lower frequency as compared to these 4 grids. Okay. So, and this Southern load dispatch center, it operates slightly at a lower frequency as compared to these 4 load dispatch center. Okay. So next I am saying this load dispatch center function, it also comes under this energy management system. Okay. So you know that this energy management system, it helps the operator in decision making. Okay. In what sort of decision making? Means how we have to control and how we have to operate the system. So it provides decision making facilities for operator in the operation and control in real time, because the operation is to be executed in real time. Okay. So we are saying how this will provide how this energy management system, it helps the operator in decision making. I already told you that this is a energy management system, it is a computer controlled system. Okay. So already some decision making programs, okay, like I told you, that contingency analysis. Okay, these analysis program, they are already loaded in the system. Okay. So this energy management system, it runs that program or executes that program, and based on the outcome of that program, it gives a message to the operator. Means some information is displayed on the computer screen, and this process takes very short time. Okay. So based on the outcome of these programs, the energy management, the system operator, it can take decision whether how to control that particular disturbance that is occurring in the system. Okay. So we can say that this energy management system, it is a collection of computerized tools used to monitor, control, and optimize the performance of generation and transmission system. Okay. Primarily function is monitor and control. Okay, first it will control, monitor, and then it will control. Okay, it is primary objective, but we also want that our power system, it should be economical. Means economical means that the cost of generation should be low. Okay, if the cost of generation is low, it will encourage the consumer to consume more power. Got it? So I am saying this energy management system, it is used to monitor, control, and optimize the performance of generation and transmission. Optimization simply means that we have to minimize the cost while satisfying the constraints. Okay. And how will this energy management system monitor? What will it monitor? It will monitor the real time data. What do you mean by the real time data? Means what is the real time frequency of the power system? What is the real time voltage of the power system? What is the actual generation in the power plant? Okay, or all the power plants that are available in the system? What is the actual power that is flowing in the transmission line? We have different transmission lines, and what is the actual flowing power that is flowing in each transmission line? So all these data are real time data. Okay. So if all these information of the whole power system, it is available at one station, it is available at one station in one computer. So simply a single operator, it can check the whole power system, and it can execute the corrective commands by sitting in the this control room. Okay, so we are saying this energy management system, it also helps the utility companies to operate their generators economically. Okay, utility companies to operate their generator economically. What do you mean by economically? Economically means to operate the system as economical as possible. It requires characteristics of all the generating units. Okay, means suppose we have a system where we have 15 generators, and 3 generators are located at one location, 3 are located at other. So in this way I will have 5 locations, and at each location I will have 3 generators, so total generators will be available, that will be 15. Okay, so now all these generators, some are hydrothermal based, hydro based, some are thermal based, some are nuclear based. Okay, so and some are this gas turbine based. Okay, so I am saying all characteristics of all these generators, if the characteristics of all the generators, 15 generators, they are available at one location, so it what will it how it will be helpful to the operator. So we can say, if all the information is available, characteristics of all the generators are available at one location, then what can we do? We can say that the most efficient unit, it should be dispatched properly along with the less efficient. Okay, we are saying, okay, this is which is the most efficient, it will take the, it will be fully loaded, and the less efficient, it should be lightly loaded. Okay, so also there was a requirement of on and off scheduling of generating units, which can be done in an efficient manner as well. Means we have to turn on and turn off a generator. Suppose for maintenance purpose I want to turn off one of my generator. Okay, so that can also be done with the help of this, efficiently with the help of this energy management system. So thus I can say that energy management systems are important for reliable and efficient operation of power system. Okay, how it is reliable and why, or how it is, or how they are reliable, how they can provide reliable and efficient operation of power system. Because we know that energy management system, it will collect data from the field, it will monitor that data. Okay, and based on the monitoring, it will take some corrective action, it will take some decisions. Okay, so with the help of these decisions, you can operate your system reliably. Okay, and also you can check the how load is to be distributed, how losses are to be reduced. Okay, so in that way you can make your power system efficient. Okay, power system operation efficient. Got it? So I can say, I told you that this energy management system, it collects data, processes that data. Okay, and it gives some decision making, it gives some decision to the operator. Okay, or it helps the operator in decision making. Okay, so means it has to collect some data, and it has to process. For processing we need some software type of equipments, like we need some programs. Okay, and for collecting data and for giving command, okay, executing command, we may need some hardware. Okay, so I can say this energy management system, it consists of both hardware equipment and software equipments. Okay, so it consists of both hardware and software parts. So what are the hardware parts? Hardware parts are the RTU, remote terminal unit. I already told you what is RTU in, I think, in your third or fourth lecture. It is remote terminal unit. It collects information from the field, and it transfers that from processes some of the information, and transfers that information to the operator who is sitting in the control room. Okay, so what are hardware parts? RTU, remote terminal unit, protection devices. Okay, like your circuit breakers, etc., relays. Okay, then your computer networking, etc. This is all hardware, comes under hardware parts. Then next is software part. So what are the software components? It is application programs for network analysis of power system. Application programs for network analysis of power system, like load flow, contingency analysis, and many other programs are available. Economic load dispatch program, unit commitment program. Okay, so they all come under this software part. So I'm saying this energy management system, it can be run in real time, or it can be run in extended real time. Okay, but the ultimate aim is to keep the power system secure. Okay, look, security is the first issue. Okay, first of all, what do you want? You want that power system should be secure. Okay, then the second step is optimization. Means second step is improving the economy. Okay, so I'm saying energy management system, in an energy management system, application programs are run in real time, as well as extended real time, okay, environment to keep the power system in secure operating state. Okay, so this energy management system is used as a part of, where this can be used, it can be used as a part of substation automation system. Substation automation system means you have a substation and you want to make that substation automatic. Okay, that is called a substation automatic system. Demand side management. Demand side management means you have to control the demand. Okay, for example, I will give you a case of though this demand side management, it is never in the hands of the company who is supplying power, it is always in the hands of the consumer. Okay, so which is a separate topic, demand side management, so I will not go into depth in this demand side management. Then comes the protection system. Okay, then distribution management system. Okay, means which is executed at some distribution level. So this distribution management system for renewable energy, because you know these renewable sources, they are called as distributed sources, or it is called as distributed generation. Okay, because we can have generation from few kilowatt to few megawatt. Okay, and it can be directly used at the distribution, and that is why it is called as distribution side management. So I am saying this, ultimately I will say that I am saying that this energy management system, it is a computer based system. Okay, and it helps to monitor, control and optimize the performance of the system. Okay, so I am saying energy management system is a system of computer aided tools used by operator to monitor, control and optimize the performance of generation and transmission system. Okay, so it has two parts. The first part is monitor and control, and the second part is optimization. Okay, so this monitor and control part, it is done by SCADA. SCADA, SCADA. Monitor and control functions, they are performed by SCADA. Okay, got it. So here I am saying that monitor and control functions are known as supervisory control and data acquisition. Means how can you control? Firstly, you have to monitor. Okay, and for monitoring you should have some real data. That is why it is known as supervisory control and data acquisition. Data acquisition, you will acquire the data and then you will implement control, which is supervisory. Means you are sitting in the control room, and from control room you are executing the control, that is called as supervisory control. Okay, that is why supervisory control and data acquisition system, SCADA. Supervise for supervisory, C for control, A for and, D for data, A for acquisition, SCADA, followed by several online application functions. Okay, so what are the objectives of energy management system? Next, so you can say the primary objective is that the system should be secure, it should be stable, and the secondary objective is that we have to go for the economy. Okay, means economic operation and control, that the control, operation and control, it should be economic. Okay, that is why economic operation and control, that is operation and control should be economic. Okay, this is secondary. And the tertiary means we have to go for planning, we have to go for maintenance, we have to go for scheduling, we have to go for optimization. Here we go for cost optimization, here other optimizations are also to be considered. Okay, so I'm saying these are the objectives. Let us discuss these objectives quickly. The primary objectives is means the maintaining the power system in a secure and stable operating state by continuously monitoring the power flowing in the lines and voltage magnitudes at the buses. Okay, so this is how we keep our system secure. Basically, for keeping the system secure and stable, we should know what is the power that is flowing in the lines and what is the magnitude of the voltage at different buses, because you know that is power flow, it also depends upon the voltage magnitudes. Okay, number second, maintaining the frequency within allowable limits, that is frequency should not vary within more than plus minus 3%, I think I told you. Okay, and maintaining the tie line power close to the scheduled values. So this is discussed in unit number 3, where I was telling you about the two area power system. That at that time I told you about this tie line power division. So means tie line power should be equal to means the power that is flowing from one area to another area through some tie line, it is called as tie line power. It should be at its standard value as per the contractual agreement. It should not vary from its contractual agreement. Okay, so next comes the secondary objective, means economic operation of power system through real time dispatch and control. PS means power system. So I'm saying secondary objective, first objective is economic operation of power system through real-time dispatch and control. Second is optimal control of power system using both preventive and corrective control actions. Preventive means suppose voltage control, we say voltage control is a sort of preventive control. We are looking that the voltage is suppose we are saying there is a sag in a system, means sag means that the voltage is dipping. Okay, so what we do, we can use the capacitor banks to improve that voltage. Okay, so and then comes the corrective control actions. Corrective control action means this this now. Preventive means we can, means before the situation occurs, we can, means prevent that situation, okay, by some stable control. And corrective control means, okay, we want to something bad has happened, or something has happened to the power system, maybe because of that thing the frequency is dipping, or because we are saying suppose that load is increasing, because of the increase in load the frequency is dipping. At that time we need corrective action, we want to correct that frequency. Okay, so here voltage control, here frequency control. Then real time economic dispatch through real power and reactive power control. Okay, this is another secondary objectives. Then comes the tertiary objectives. Okay, tertiary objectives, optimization of power system for normal and abnormal operating scenarios. Okay, this is the overall optimization of the system. And then maintenance scheduling of generation and transmission system. Okay, so maintenance scheduling of generation means, okay, we have a daily load curve, and at which time we will turn a particular generator, and how that this load is or how load is distributed among different generators. That is called maintenance scheduling of generation. Okay, so similarly we have to maintain the scheduling of the transmission system as well. So I am saying these are the three objectives: primary, secondary and tertiary. So these three objectives are executed by operator at different levels in a control center. Okay, I am saying voltage magnitude and power flows over the lines are continuously monitored through SCADA system to check for violations. Okay, now I'm saying we have to, with the help of SCADA system, we can continuously monitor and check the violation of voltages or the tie line power, or the power flow that is flowing in the transmission lines. Okay, then voltage control or voltage violations are addressed by preventive control actions, and power flow violations are addressed by means of corrective control actions. Okay, for voltage violation we apply preventive control, and power flow violation we apply corrective control. Okay, and that we say tie line flow at scheduled values will be maintained by adjusting the megawatt outputs of the automatic generation control generators so as to accommodate fluctuating load demands. Means suppose there is some change in the load demand, because of that change in the load demand, what will happen, the frequency will change. If frequency will change, what will happen, tie line power division will change. So what we have to do, if there is some load demand in one area, we have to take care of load demand in that particular area, and that care will be taken by what, it will be taken by the governor control. Okay, so which is called as automatic generation control. Okay, so if there is change in demand in one area, the governor of that of the generators in that particular area, they will adjust their setting so that the generated power will become equal to the total demand. Okay, so that the frequency deviation, it reduces to zero. So once the frequency deviation reduces to zero, tie line power deviation, it also reduces to zero. And at that stage we will say that the power that is flowing in the tie line, it is at its scheduled value. Okay, next let us discuss about the evolution of the power system, evolution of the energy management system. It is not like okay, we are talking about the energy management system, so energy management system was existing since we means the first power system came into picture. Okay, it is not like that. So we are saying this energy management system, it is named in, it has different names. Okay, the first name I am saying ECC, energy control center, then LDC, load dispatch center, then DMS, demand side management, and fourth is DMS, distribution management side. Okay, DSM is demand side management, and DMS is distribution management side. Okay, so main function of all these ECC, LDC, DSM and DMS, now their main function is to operate this real power system in a real time in a secure manner. Okay, so if I will talk about the evolution of the power system, so we know that in 1960s we started with the control centers in 1960s to fully development energy management system. Okay, so in 1960s, control centers came into existence. So the term, and they are termed as control centers. Okay, and their main function was were initially termed as load dispatch center. These control centers, they were initially termed as load dispatch center, and task was to control the power generation and demand to match the generation and load demand. Okay, so this main function of the control center, which were termed as load dispatch center, their main function was to maintain a balance between generation and demand. Okay, so then in 1970s, their name was changed from control centers to energy control center, though with some additional functions. Okay, so here the main task was to match the balance, to make a balance between generation and demand. Here the task was to control the energy rather than power. Okay, in control system we were maintaining a balance between the power generated and load demand, means power demand and power generation. But in energy control centers we were maintaining a balance between the energy generated and energy demand. Okay, so here power monitoring was the main concern, and here energy monitoring was the main concern. Okay, so matching of energy of demand from that of the power generation was the main concern in energy control system. Then in 1990s, energy management systems, they came very late, means 20 years after energy control system. So then came the energy management system. Okay, so main task of this energy management system was to manage the energy through various techniques, means to manage the energy through various techniques. And what were the techniques? Means load management, demand side management, distribution management system. So by these methods we were means maintaining the balance between energy demand and load. So this energy management system, they are computer based programs that performs both computational tasks as well as decision making tasks, so as to assist the operator for real time operation and control. So if you will see here, it is not the balance of energy generation and demand. Here the economic decision making, it also comes into picture in economic in energy management system. However, economy was not a concern in energy control system and energy control center and simply control centers. Okay, so now let us discuss about the functions of the energy management system. So like the objectives of the energy management system, the functions of the energy management systems are classified into 4 categories. Number 1 is control functions, number 2 is operating functions, number 3 operation optimization, and number 4 planning functions. So let us discuss the functions of the control function first. Okay, so the control functions are real time monitoring and control functions. Okay, we will obtain the data in real time, and we will implement the control in real time. Okay, then second, efficient automatic generation control and load frequency control. So this load frequency control problem, it comes under control function. Okay, the third is optimal automatic generation control across multi areas. Firstly, we are talking about the load frequency control. It was for the load frequency control of single area power system. Okay, if we have multiple areas and these areas are connected via tie lines, then we have to go for optimal automated generator control across multiple areas. And the fourth control function was the tie line power flow control. Let me write it completely: tie line power flow control. So these are the control functions. So next comes the operating functions of the energy management system. So the first operating function is economic and optimal operation of the generating system. Economic and optimal operation of the generating systems. And the second is efficient operator decision making. So this means it will this energy management system, it will help the operator in efficient decision making. Okay, the third is the optimization functions. So we have 4 optimization functions. The first is optimal utilization of transmission network. Means we have to see that if we have a transmission network, suppose that we are saying that we have a transmission line with a capacity that can transfer 400 megawatt of power. Okay, so we will make sure that it should be loaded up to its full capacity. Okay, so we are saying if we have designed it for 400 and we are only transferring 200 megawatt of power, so we are saying that this 200 megawatt, which is not, means we will say that the transmission line is underutilized, it is not fully utilized. Okay, second is power scheduling interchange between areas. Means how we have to supply power from or we have to schedule the interchange of power between two areas. Means when power will be supplied from area 1 to area 2, or when power will be supplied from area 2 to area 3. So this is called as power scheduling interchange between areas. Third is optimal allocation of resources. And fourth is immediate overview of power generation, interchange and reserves. Means we have to see what is the power generation immediately. Means if we want to, so there is some disturbance in the system, immediately we have to see how this power generation, it will change, it will vary from different generators, and how this power that is exchanged between two areas, it will change, and what will be the reserve, how much spinning reserve is left there. Okay, so these all come under optimization functions. So fourth is the planning function. So planning functions we have: improved quality of supply and system reliability, forecasting loads and load patterns, generating schedule generation scheduling based on load forecast and trading schedule. This is generation scheduling based on load forecast and trading schedules. Fourth, maintaining reserves and committed transactions. And fifth is calculation of fuel consumption, production cost and emission. Mean, look, what comes under planning means what is the production cost, what will be the production cost, it has to be determined initially. Okay, while making the plan, you will have to determine the production cost, and as well as the emissions. Means emission is a very important problem nowadays. Okay, because you know that these thermal power plants, they they produce a lot of these greenhouse gases. Apart from these greenhouse gases, it produce tons of this ash. Okay, so this ash handling is another problem. So we have to go into, means these things are to be considered initially at the planning level. Okay, so this was all for this energy management system. Okay, so please go through this lecture carefully. Okay, and in case you need notes, your respective CRs, they can talk me, and I will provide them these notes. Okay, for study purpose. Thank you very much.